compressible flow, speed of sound, and Mach number. I think everybody knows Iron Man and Superman. So the advantage of them is it could fly. And then if we watch their movie carefully, we found that sometimes when Iron Man fly, after a certain velocity, after a certain speed, we could see a cloud formation around his body, like this. We could see the same phenomenon in Superman. So this is when he fly at certain velocity, and then when he become faster and faster, we could see clearly there is a cloud formation around his body. So we could see the formation of cloud. So what I would like to discuss here, does it really exist if we could fly as fast as Superman, or it is just a computer graphic in Hollywood films? If the cloud is a true phenomenon, so what is the meaning of the presence of the cloud? So what we could say is the phenomenon of cloud formation that we could see in Iron Man and Superman bodies is actually a real phenomenon that occurs when our speed reach Mach 1, which is equal to the velocity of sound. When the object moves fast, the air around the object is compressed. The presence of water vapor in the air forms that we see as clouds. If the object moves faster and the object is able to break through the cloud, an explosion will be heard. It is called a sonic boom. Usually, after an object reaches Mach 1, an explosion sound will be heard. Another example are volcanic eruption. If a volcano erupts violently, air in the volcanic area will rapidly compress. It will form a shock wave. It can break down car mirrors and buildings' mirrors. To explain this one, I would like to show you a picture of jet fighter F-18. So you could download or you could see this video and you type by using the keyword of shockwave in jet fighter. So this picture is a picture of jet travel or flight just before the M1. We could see that a very blurred cloud formation can be seen here. And then when it reached Mach 1, we could clearly see a cloud formation here, exactly the same cloud formation that we could see in Superman and Iron Man. It means that they are fly at Mach 1. And then when it reach, when it go faster and faster beyond Mach 1, so the sonic boom occur and the cloud formation here will disperse. And then, but in this video, we could see a little bit of cloud formation after it reached Mach 1. To explain that formation or to explain that phenomenon, we need to know about Mach waves. So let's say we have one source of sound at this point and it is fixed at this location. So and then every second the sound source here will release a sound wave. Every second it will move from here to here and so on. So means that after 3 seconds a sound wave from the origin will travel until this area. And then 1 second after that one will travel until to this area, and just 1 second release sound wave will travel to this one, to this area. And then we could see that we could hear all the sound here because we are stay at the sound at the source of sound here. Let's say we are moving a little bit, mean the source here is moving from here to here, to here, and to here. Okay, and then it's moved with certain velocity. Okay, so let's say the velocity from here to here is constant. So we take a simple calculation. The distance or the time between each move from here to here is 1 second. So at this point, so means that it's already moved in 3 seconds. So while this source at this point, so it releases a sound wave and it's already moved for 3 seconds. So means that the area covered by that sound is here. So and then when it moves here, the sounds released and it's covered until this area, and when it move here, the sound is just released. So this is the area covered by the sound, and finally it reached at this point and the sound is not being released. So you could see that if we travel, so we could still hear the voice or the sound of our engine because we are still inside the sound wave. However, this sound wave is become not symmetrical anymore because we move from left to the right. Okay, so for an object traveling at a speed greater than the speed of sound as shown below, it cannot hear its own noise. The region outside the cone is a zone of silence here. So that an approaching object moving at a supersonic speed could not be heard until it passed overhead and the Mach number cone. The cone shown intercept the observer. So this is where our source moving faster than the speed of sound. So means that starting point here, so our source release the sound wave, and then after 1 second, and another 1 second. So it's mean 3 seconds before from its original distance, original location to this final location. So, and the speed of sound is constant. And then we, at this point, because this point is already 3 seconds from the current location here, so the sound wave is bigger. And then the second one is a little bit smaller, and this is the next sound wave, and wave here is just begin to spread. So we could see that the cone here is a tangent on the mark on the wave, on the sound wave here. So means that if we reach Mach number 1 or greater than Mach 1, we cannot hear our own noise because the sound is slower compared to the speed of ourselves here. So we call the formation of triangle here as Mach cone. This is the formation of Mach cone from the previous slide. So from here we could simplify our drawing like this. So we take the largest Mach wave here, sound wave here, and then we draw a circle here, and the distance from here to here can be represented as v, which is the speed of the source. And then as we learned previously in potential flow, source means its flow as a radial here. So means that we could say that the sound moved from source here with the direction of radial. So the distance here is c, the speed of sound. So from this diagram, we could draw a triangular shape with a 90-degree here. So we could say that if we assume that this angle is 2 alpha, now it's become an alpha. So the relationship between alpha and these two terms, c, speed of sound, and v, velocity of object, we could say that the value of alpha here, the angle here, can be found by reverse sine c over v or reverse sine of 1 over m, which is m is the Mach number. And this is a shock wave observed in experimental. So we could conduct this one in wind tunnel or water tunnel. So what we need to do is we put a sphere here, a steel ball here, and then we flow with a high speed wind tunnel, for example. Because in real situation, the atmosphere here is zero and our object will move at certain speed. But in experimental or in laboratory, what we do is we make our object here static and then we move the fluid at certain speed. So after it reach Mach number 1.53 according to this experimental work, we could see clearly a borderline here which create the Mach cone. This might be the best graphic for you to understand how shockwave develop when we move faster and faster until we reach Mach number 1 and more than that. So for example, we have one object here and this object produce noise. So it might be come from our engine and so on and so forth. So if the object is not moving, so the wave sound will disperse like this. So if we move a little bit with low speed, so might be the sound wave will look like this. So it's a, a little bit denser at the right side here. So and then when we move faster until we could reach the sound of speed, so we could say that this object now is moving at sonic speed. So sonic speed means the Mach number is 1 and we could see that the sound of sound wave is very dense here and the shock wave was created. At this time, we could say that the shock wave will create perpendicular to the movement here. So however, when we move faster from the sonic speed, so let's say we are moving more than Mach 1 here, so the sonic speed, the shock wave will become like this. So this is another idea about shock wave. So if our object here, our big jet, fly in subsonic flow, there are no shock wave. This is very clear. And when we have a supersonic flow with a very low, for example, with Mach number 1.06, so we have shock wave. But according to the common observation, we could say that the shock wave is detached from the object here. So and then if we fly faster around Mach number 1.45, so we already reached the supersonic flow, so and we find that the shock wave is now attached on our object here. So the word oblique here shows that the shock wave is not perpendicular, it occur at certain angle from compared to the movement of our object here.